All right, so just like we have done before, I'm going to go quickly over the PowerPoint to go over some of the concepts that we will be covering, and then we'll come to the MySQL. And as I mentioned earlier, most of these computers probably would have the MySQL downloaded, so we'll play with it, but I'll also take the time to go through and show you how to go ahead and download it, because if you are going to be working on the working with your last bit of Java code, you would need to have your MySQL downloaded on your computer. If any of you guys have the MySQL database downloaded in your computer, you're good. You don't have to again download it additionally. You should be able to make the connection and do the Java code from here. So those of you guys who have taken the database management class probably have something downloaded. You don't need to download the WAM server. So I'll go over that as well. So very basic, what's our database system? And our databases are nothing but I kind of give the analogy that a database is kind of like a folder, and that folder would have a lot of tables inside, just like you have files. So when we talk about a database system, we are talking about that entire folder structure with all the files in there. But again, the files that are inside that folder are not easily accessible, just like you open the folder. You actually have to go through an application or some kind of a software application to get to those folders. So a database application is where you would find a basic database, but then it would also be layered with a middle layer application through which you are going to be reaching out to that data. So you are going to be interacting with the database through that middle layer database application, and it would give you an interface, and depending upon which database system you are using, you would find tools that would give you either a GUI interface or a command prompt interface, so that you would be interact with the database system and create your own data, create your own database, create your own table, insert your values, update your values, drop tables, add tables, and do all kinds of updates. So we have our application users sitting at the very top. So those are the people, or us clients, who are interacting through our computer screen. Application program is what we just talked about. So you're interacting with that tool. That's your application program. And this is your database management system. So that's the one that is sitting in between the user and the database. And a lot of time, the system users, basically they are the DBAs who are interacting also with the database management system. And these people, the only difference is that they might have a few more rights to configure or set up the database so that these users would use them appropriately. So you do not have the users have full control of the database system, because you want to assign them certain rights, because it is important that you keep your database controlled or managed. You do not want everybody to have access to the database for the security or for maintaining the integrity of the data. So this is another pictorial, or another way of showing how you're using your database management system. In this case, they're basically showing that you have not only one but multiple databases, and generally if you're dealing with a bigger system, that is what you're going to have. You're not going to have one, you're going to have multiple database system. Rational database and relational data model. All these little tables that we create inside our database, these tables are not created arbitrarily. In this class, we are not going to get into the design of the table, but it is important that you all know that those files, okay, remember that analogy of a folder and then the files inside, those files that you store inside are actually logically arranged. For example, let's say you are trying to store information about different students, right? So one way of doing it is create individual files for individual students, right? But then you might store information about their classes, okay? And that would be a separate folder structure, okay? So in one folder, if I'm keeping all my student files, then in that folder, I'm going to have individual students have their individual files. So these files that I'm storing basically have some kind of a relationship. I do not arbitrarily store everything in that same folder. However, in the other folder that I have, where I want to store information about the class, I probably would have information about each class, their descriptions, their number of credits, everything, the master course and everything. So that's how I can have a folder structure, and inside the folder you would have files that are going to be related. Okay, you do not want to mix everything together, because then it is hard to manage, it will have redundancy, and it will be very difficult to update or delete things when you have everything mixed, because you're spending a lot more time to go through and clean that up. Similarly, what we do over here is, when we talk about our databases, we are talking about a relational database system based on a relational data model. So those data that you're storing in those tables, they actually follow a design pattern to store that information about one entity, and we'll talk about what we mean by an entity. So think about the analogy that I just gave. If I want to store information about students, individual files for one's individual students, that's going to be all in one table. In this case, we were going to create this one table. All those related information about students are going to be stored there. When we talk about the classes, we're going to create another table which is going to store all information about the class. The way we will connect the class table and the student table is through some keys, primary keys, foreign keys, and even though I keep the information in two separate places, with those keys I should be able to connect those tables and extract information according to my need. So if I want to know from the student table, this particular student, what classes they have taken, I can connect those two tables and pull the information together from these two tables to come up with my classes the students have taken. And of course, there are other tables that I can also create, and we are not going to get into that, but that also goes into designing the database. Okay, for our purpose, we just need to know that these individual files that we are keeping, they have some kind of a relationship with each other, and it's important that the relationships are maintained, because that is going to help us extract the information. Otherwise, it becomes difficult to extract that information. So a structure in this case, so let's talk about this. A relational data model has three key relational data model components, which is a structure, integrity, and language. Okay, so let's talk about what we mean by structure. Structure defines the representation of the data. Question about that? Are we good with that, with the analogy that we just talked about? Again, let's not get into too much into the database, but just general information. Integrity imposes the constraint on the data. I did not talk about that. I talked about the relationship, how we need to separate out the information about a student and a class. What we mean by integrity is, sometimes to avoid errors in the database, we might impose some relationships. Something like, if a student is signing up for a class, the class has to already exist in my class table. That's my integrity rule. Okay, so this is going to avoid somebody inputting something in the database by error. So I'm trying to say, okay, John is going to try to take this class COP2800, but somebody by mistake types this class as CAP 2800, CAP 2800. it's immediately going to get caught in that integrity rule, because in my folder which stores all my class, this COP2800 is not there, right? So what I'm saying here is the class has to already exist before a student can sign up for it. Okay. Similarly, all throughout our database relationship, you will find those kind of integrity rules. Basically, the foreign key and the primary key that we talk about are those integrity keys or integrity rules. When I say I'm going to include a foreign key in one of my table, what I mean by that is, okay, I can include that foreign key, but that entity has to be there in a different table. Okay, so that's my integrity. And language provides the means for accessing and manipulating the data. So when you saw that earlier slide about your application users interacting with the database management system, they are going to do that by using a language. Just like Java language, we also have a language, and we call it the query language. It's also referred to as SQL, structured query language. And depending again upon the database that you're using, those languages may vary a little bit between each language or between each database. But in general, you would still have a select, you'd still have an insert, you still have an update, you still have, the regular joins and all that stuff. And for our basic SQL languages, we are not going to get into the complex joins and stuff. We're going to just learn about some basic things. How do we create our database? How do we create our table? How do we insert our values? How do we update any of the contents inside the table? How do we delete the table? How do we delete the database? So that's basically my 5 or 6 basic things that I'm going to be learning over here. But you can do a lot more. Okay, for the management purpose, you can actually assign rights. You can assign who gets access to what. You can do several kinds of joins between tables. You can extract information. There's a lot of things that you can do. You can even do some mathematical calculation by writing some SQL statements. You're trying to, let's say, do a count. So not only do you need to go through the individual select statements, but then you have to add them together with a count to see how many records that you have. So there are a lot more that you can do, but for our purposes, we are just going to stick with some of the basic SQL statements. All right, kind of talked about it already. Relational database consists of a set of relations. A relation has two things in one: a schema and an instance of a schema. The schema defines the relation, and an instance is the content of the relation at a given time. These are important information for your quizzes. The important thing over here is this thing, the basic thing, which is a table with rows and named columns. So think about a table. You have your rows. Those are your horizontal columns. Those are your horizontal rows, and then we refer to as columns. Those are my vertical columns that we are referring to. So this is an example. So learn the terms. You might see some of these terms being used for your quiz purposes. Rows, also called tuples, and then you have your columns. These are my column attributes. So course ID, subject ID, course name, title, number of credits. These are all my column names. And this row would have information. So this particular one, course ID, and in most cases, this is going to be my primary key. So when I say I have a course ID 11111, this is going to uniquely identify this entire row, or sometimes I'll refer that as one record. Okay, so if I ask you how many records do I have 1, 2, 3, 4, 5, 6, 7, 8 records. Okay, one record is my entire row. So when I say 11111, that would identify my entire record. This number has to be unique if I refer to this as a primary key, which means this number cannot be repeated in my table. That is what is going to make it a primary key. Okay, so if I see another 1111 mentioned in here or written over here, that's wrong, because if I call this one as a primary key, that is not possible, or that should not be possible. A lot of times in your database system, if you define that as a primary key, you try to input another record with the same number, it's going to stop you. It's going to give you an error. Just like your Java language, if you try to define a function and then you try to call a function with a different name, it will give you an error. Same thing. Okay, so that's your primary key, and that's going to give you an error. So know about some of the terms: rows and tuples, columns or attributes. And so these are my vertical ones are my columns, my horizontal ones are my records. So two examples of tables. This is my course table. This is my student table. Now again, in this case, you will see that I also have my SSN. Now this is just an example, but kind of a bad example. You do not want to have your SSN number as your primary key. You would probably assign its own primary key. And again, if this is my primary key, this number cannot be repeated over here. If it is not a primary key. So here is my student table, and it has information about the student. Now, earlier I was referring to, or I made a statement saying, when I create these tables, you saw the student table, you saw a course table earlier. When I create this table, these tables are just not created arbitrarily. There is a logic of, or there's a system put in place which tells you how to design these tables, which means what are the columns that I can include in this table. Okay, so in my class table, what are the kind of columns I need? For my student table, what are the kind of columns do I need? And these two tables should have some kind of a relationship between each other. All right. So we saw these two tables, class and student. This is more of an associative or association table, where it actually uses one primary key of one table and another primary key of another table. And this table would probably have as a primary key both these columns put together. So what we now have is something called a composite key, which means I have two columns acting as my primary key. You guys with me? Which means now this is not a primary key by itself, because this number may have been repeated somewhere. Actually, it is repeated right afterwards. Okay. However, the combination of this and this cannot be repeated. So this primary key is a composite key, which means it needs two of these things to be considered a primary key, and a combination of this and this, 4 4, all these 1 5s and this can never be repeated. So this combination cannot be repeated in the table. All right. So you can go through and see any of these combinations are probably not repeated. But this is something that you created, you called it enrollment table, where I can, if I create a table like this, I can now easily go back and find out what this student have taken in their entire college career. Or I can even break it down and see, okay, what this person has taken in spring or fall. Again, how do I do that? That's where my design of those initial tables come in. Okay, but this is my table which puts those two things together. Table versus file. Technical term, a table or a relation is not the same as a file. Most of relational databases store multiple tables in a file. Now, this is an important thing to note, because I just gave you an analogy of that file and folder, right? But pay attention to this. A table or a relation is not the same as a file, because when I talk about a file, most of the relational database systems store multiple tables in a file. So the technical term of a file could be where you have multiple tables stored in there. You guys with me? So you can have an Excel file, but it can have multiple tables stored in there. So for technical purposes, that's not correct. But for the analogy, when I say it's like a folder, this is where I'm going to hold everything, and individual pages are my files. Already talked about the integrity constraints. It kind of defines it again. When I talk about those primary key domain constraint, primary key constraint, foreign key constraints. So it basically tells you a domain constraint and the primary key constraints are known as intra-relational constraints, and the foreign key is known as the inter-relational constraint. So good information. So this is showing you the domain constraint here. So what I just mentioned earlier, this is kind of showing it again. So what it's telling you is, if this is my enrollment table, and if I have Social Security and my course ID, what I mean by the domain constraint is, if I try to write this course ID 1111, if this course ID is not present in this table, then I cannot write it. It's going to give me an error. Okay, so it says each value in course ID in the enrollment table must match a value in the course ID in the course table. So if I do not have a course called 11111, then in my enrollment table, if I try to put that number by mistake, it's going to say, no, that is not available. So that's basically my constraint. All right. Other things that you can do is number of credits, and this kind of goes back to how you're setting up your attributes. You can set up integrity controls in your attributes. For example, I showed you that this attribute or column, course ID, is having numbers. So when you define the database and you define your table, you will have to mention in that table what kind of value are you going to hold. Are you going to hold a number, a character, a varchar, a date, a timestamp? So it would allow you to choose the data types. All right. In technical terms, these are more of the data types that I'm defining when I'm defining this course ID column. All right. And in my data types, I can also add constraints like this number can be a number between 3 to 5 digits. So it cannot be less than 3, it cannot be more than 5. And that is going to be driven by my business rules. However, I want to define my ID. Okay. Same thing over here. So individual ones, I can create its own rule. For example, if I'm trying to define something with in my subject ID, it has to start with the to preface which determines the department. Could be. And those are business rules that you can make up. Another one over here, number of credits. When you're trying to input some credit, you can put something like it cannot be 0 or it cannot be more than 4. Because in most cases, most of the organization would probably have a number. Because if you do not put some limitation, there is nothing stopping from a person, there's nothing stopping a person coming back and putting a wrong number saying 40 over here. Right? So you can also define, there could be 2 rules. It has to be one number and the number has to be greater than 0, less than 5. Because that's going to satisfy most of your requirement. Primary key constraint, again, I'm not going to go over this. I kind of told you what this means. So one has to be already there for you to be including that in the other table. Question about it? You're good? Again, those of you guys who have taken the database class, it's pretty simple for them. But if you have not, make sure that you understand the basic concept of what we mean by the constraints. All right. So remember I talked about some of the basic queries. So these are the basic queries that I want you guys to be aware of. Again, you don't have to memorize. You can look at or you can reference, but try to understand. It's pretty simple, straightforward. Just like it says create table course. And again, some of the database rules, they're pretty forgiving about how do you write the case of your SQL statement. Some people write it all caps, some people write it mixed, some people write it in all small letters. This is fine. It's going to tell you if you miss something. So if you miss a comma over here, it's going to say, wait, there's a SQL error over here. But it would not make any difference with those cases. So create table course. So this is the name of the table. You start a parenthesis and you end your parenthesis. And then you define the individual column IDs and the data types that you're defining, that you're allowing in that column ID. And they're all separated by comma. All right. So your general template is create table course. Course ID is your column name. It is character, size of 5, comma. Again, the next column ID, which is subject ID, character 4, not null. What does not null mean? You cannot leave it blank. Thank you. So this subject ID, you cannot leave it blank. Quick thing to mention over here, most of the primary key are going to be not null, because you cannot have a primary key, or you cannot allow for a primary key to be null, because that is telling you that I'm not identifying my row or my records uniquely. All right. Course number is going to take an integer. Title, it's a varchar, it's one kind of a data type. 50, so it defines the size. Again, not null, you cannot leave it blank. Number of credits, integer, comma, and then it says this number of credit, it has its constraint greater than 1. Check number of credits greater than equals 1. So if you put in number of credits as 0, it's going to say, wait, not going to work. Can I put something as 1? According to this, yes, because it is greater than or equal to 1. Everybody good with this? Simple? All right. Super key. A super key is an attribute or a... Those of you guys who are in my database class have heard about the super key, candidate key, primary key a lot. So a super key is an attribute or a set of attributes that uniquely identify the relation. Now this one statement is pretty much going to be true for all these keys that you're going to be seeing. So it is an attribute or a set of attributes that would uniquely identify the relation. That is, no two tuples. What are my tuples? My rows, right? No two tuples have the same values on the super key. So that 1, 1, 1, 1 that I showed you cannot be repeated. By definition, a relation consists of a set of distinct tuples, rows, all right? The set of all attributes in the relation forms a super key, all right? So in a table, can you have multiple super keys according to this definition? Possible? No? So let's go back and take any of these tables, maybe individually a table. Okay. From here, can I select multiple super keys? So let me give you some examples. So can a combination of Social Security and, okay, can individually Social Security be a super key? No. Okay. Because why? Because I'm seeing a repeat. Can a combination of 4411 this and this be a super key? Yes? Okay. Can a combination of course ID and date registered be a super key? No? Because you have this 1111 repeated with this with the 2004-319, right? What about a combination of Social Security, course ID, and date registered? So then I can have multiple super keys, right? So I talked about how in this particular table, and again, remember, when we talk about super keys and we are looking at an example, we are looking at that particular table, right? So I can have a combination of these two as a key, this, and this as a key. Can I have a so you have to go in and check every single column. Can a combination of this, which is course ID, date registered, and grade, be a super key? So you have to go through, and now again you have to go through the table and say, okay, is this thing repeated multiple places? So this, and this. So 1113 with a 319 and a B, 1113, 319, I have an A. So I have to go back and look to see if I have a repeat or not. Yes, Jill. When we say a composite key, we mean more than one column. A super key could be composite key, yes. But a super key is basically a set of keys or set of attributes that can uniquely identify, right? So you can go through and see that there may be multiple combination, potential combination that you can define as a super key. All right. So coming back to this one, I can have multiple super keys. The word super basically says it's a set of a many or a set of multiple columns put together could uniquely identify. All right. So that's my super. All right. All right. A key. Then I say a key K is a minimal super key. What do I mean by that? Remember how I showed you in the previous table where you can have a combination of your Social Security and a course ID, but then you could have a Social Security, course ID, and a date, or I can have a course ID, date, and maybe a grade. So I'm saying among all those sets of attributes, a key would be my minimalistic combination. So if I have a set of 3 combined to be a key, a set of 2 combined to be a key, a set of 4 combined to be a key, in order for me to choose that key, I would probably go with the minimalistic combination. Everybody good? So a key is a minimal super key, meaning that any proper subset of K is not a super key, and you can really get into some good math with this, sets and subsets and things like that, but for our purposes we'll kind of keep it simple. It is possible that a relation has several keys. In this case, each of the key is called a candidate key. So is candidate key a super key? No. Is candidate key a super key? The answer is yes, because remember, a super key could be, there are multiple combinations, and one of those combinations could be a candidate key, right? So I had shown you earlier combination of 2, combination of 3, combination of 4, all of those things are super keys, but one of them, the minimalistic one, is my candidate key. So the answer to is candidate key a super key? It is a potential, it is one of the super keys. No, you have to be, because how would you choose that as a candidate key? Remember, because super gives you multiple possibilities. Candidate is the one that you choose from them. And when you choose, you basically go with the minimal subset. All right? So in this case, each of the keys is called a candidate. So remember those individual combinations that I created? Each of them would be a candidate key. Right? So I showed you 2, 3, 4 set of those attributes. Each individually could be a candidate key. That's right. So we can define that as a candidate key, which means it could be one of the keys. Okay? And then there is really very little difference between a candidate key and a primary key. So primary key and candidate key, they're still part of the bigger subset of a super key, but the one that I choose becomes my primary key, and it is pretty much chosen by the DBA, right? So a DBA can decide to choose one of the candidate keys that we have identified, and let's say that has a combination of a social security number. But I have a possibility in that set where I can actually find a combination which does not include the social security number. All right. So I can make that my primary key because that's a better fit, again, chosen by the DBA, which probably fits my security rules for me. Right. So I can come up with something called a student ID, and I say, okay, I'm not going to use, so I can, for example, in our case, we store information about your social security, and also I have a student ID, but it's up to us to decide what we are going to be choosing. And it's scary to know that 10 or 15 years ago, you know how we are logging into this system, our D2L system? Every single one, when you log in, if you look at the URL, they actually included your social security, create your own instance. Okay, so, and all of a sudden we noticed, I said, oh, wait a minute. When I look at my URL, it's my social security that identifies and creates my instance. Okay, but it was a bad choice. So once we realized that, we said that's not something that we're going to be doing this, so we changed. So what I choose between candidate key and primary key is going to be determined by the DBA and by some of the rules. All right. All right, so the primary key is often used to identify tuples in a relation. But remember, all these uniquely identifying, that uniquely identifying factor is true in super key, in your candidate key, and also your primary key. Everybody good? All right. All right, Jerry, go ahead. So the keys are like parameters. Keys are like parameters. Um, Not quite, Jerry, because uh, the parameters does not have to be unique. I think if you're meaning the parameters would uniquely identify, the signature would be uniquely identifying a function, yes, you are correct with that. So uh, if you're referring to Jerry as, let's say you have two constructors, and one constructor uses two parameter versus the other one uses one versus the other one that uses three. So yes, the one, if you pass a parameter which takes one value, you can understand that that is going to identify, or that is going to identify the signature of that constructor which takes one parameter. But it does not have to be unique, which means you can pass the same value again. So in that sense, Jerry, it is not unique, but yes, if I have three different signatures, it would identify that particular function. Does it make sense? Okay. Um, and also, since you asked that question, another question that Jill had asked was, why do we call it? What was the question? You, yeah, you asked, oh, why is it that we? Right, but what was your question? You asked that question. I can't remember now. Um, okay, so the question was, why didn't you call a candidate key a super key? Okay, so that was the earlier question that we were talking about, how a super key could be, a potential super key could be multiple combinations, and then you choose the candidate key, which is the minimal set of the super key, and then between candidate and primary, I choose which one fits my need or my rules better. But I can easily go and choose one of the other candidate key as my primary key. Okay. Let's take a break. So let's go back and finish out the sequels. So here you have a primary key, and what I'm asking you to pay attention to is the SQL statement here, create table course, and this is basically what it, how you would create a table with all your column ID, and this is your primary key constraints. We already talked about it, foreign key constraints, so basically telling you that, you know, if it is not there, you cannot define or create that. And this is the relationship. So formally, a set of attributes F key or the foreign key in the relationship R that references the relation T if it satisfied the following two rules. Okay, so it's basically showing you that. Here is the foreign key example. So create table enrollment, social security number, character, course ID character, date registered is a date. These are our data types. And then you have a primary key, foreign key, and foreign key. Okay, and look at how we are saying foreign key with references student, foreign key course ID references course. Okay, again, do not try to memorize this. You will always have these as a reference. Just understand what they're doing so that you can write your own statements for your own purpose. Tells you the same thing that we already talked about, discussed. All right, so SQL, this is the statement that we are talking about, or you had seen earlier, those create statements that you saw. So SQL or SQL, and excuse me, here are some of the examples of my SQL statements. Again, we'll stick with the very basic one. So create table. So this is what this is doing. This is saying create table course, create table student, and then the column IDs that you have, or the column IDs of the course table. So the part that I want you to pay attention to is, for your assignment, I'm going to ask you to create maybe another table. It's not going to be a course table or a student table, but some other table, and I'll give you some column names. So basically, you would then determine how to write these SQL statements. So use that as a template and change your name of the table and the column attributes that you want to do. Drop table. So this is how you would, once you have created your table, you can always go back and drop it. And this is how you would do it. Drop table enrollment, drop table course. Describe table. This is basically what's going to describe the data set. So it's going to tell you, if you write a table, what the table column IDs are, what their values are. You can write select statements, which is going to give you or extracting information. That table that you earlier created doesn't have any values, and the way you would insert the value is by doing this: insert into course. You're going to name the table, and then you're going to name the fields in the proper order, and then values again in the proper order. Okay, so this 1113 is going to be going to course ID. So if you mess up subject ID with course ID, then this is going to go in place of a subject ID. So the order is important. And then you have your delete, then you have your update. So if you, let's say you put something as 2, but you want to go back and update the record, you can do this with an update statement, and you have your delete system or delete database. Any question with that? Okay. So this is kind of taking you to the next stage. Why do we use Java? Now, anytime you write any program, of course, in most cases, most of our programs are web-based nowadays. Okay, our system is one of those examples. Okay, it may not be using Java, but again, it is web-based, and it is always interacting with the back-end database. Now, few years back, you actually had a web presence which basically connected or gave you links from one document to the other. So the web page used to be a place where you could find information. Actually, before we switched into this new system, that is how our system used to be. So you could find information about program guide, college, history, students, all the different departments, how to put contact, how to get the contact. So everything about the college, all the information was on the web page. But the web page wasn't transactional, right? So what we have done in our web page is we had gone back and really changed everything so that now everything is off the web. So anything that I can do in the classroom or within the LAN environment, I can do the same thing from an off-site location. All right. So from off-site, I can register, I can go into my classroom, I can pay my fees, I can apply for it, I can apply for graduation, I can do everything from offline, which means now we are interacting with some kind of a database so that I can have updated information, right? So that is true because when you are trying to register during the scheduling time, that's when you'll see the most updating going on. You see a class with 20 openings, and next time you log in, it's down to 15. The next time you log in, it's down to 5. Okay, so our web system is now a transactional system, and that is why whatever language that you use in the front end has to be connected to and be talking to a backend database to be extracting information and then processing and showing it on your screen for you to interact or transact. Okay, so that's basically what this is talking about and why it is important. The database application, we have our GUI, we have our client server and server-side programming. So this is just the architecture. That's our JDBC, our database connectivity. The JDBC interface, again, since we talked about Java, we kind of saw these things earlier. And when we create, so this is basically what we are going to be doing with our program. So in our program, we will include a driver when we write our program. We will include a connection that will start the connection. Then we will include some statements, and the statements could be creating my database, creating my tables, inserting my values, updating my values. Okay, select something from there. Now, once I go to the select statement, okay, so once these statements are how I'm creating or inputting my values. But once I do a select, that is going to come or fall into this result set. Now, all the information that I have inputted already, I want to now receive or see that. So that's going to be my result set, and that's going to be pretty much my select statements. Okay, so we will do this in maybe 3 sets of programs. So we'll start off, and it's the same program. So the first one will basically establish the connection. The second one will create a database. Now, in order for you to create the database, you have to establish the connection. Okay, the third one is inserting the value, but again, to insert the values, you have to establish the connection, include your statement, and then input your values. Okay, and the last one is extracting the result set, but again, you have to still make the connection, you still have to connect to the database, and then you're going to extract the values. So the 3 programs or the 4 programs that we write, same steps are going to be repeated multiple times, because think about the logic. You're connecting to the, first of all, making the connection, connecting to the database, and then extracting information. This is what we are talking about. So the driver class is basically given by this code over here. So we will say sun.jdbc. So this is the driver sequence. Then you have the MySQL, Oracle. So depending upon what language you're using, you're seeing those individual drivers. And we'll see these codes later. So this is a simple JDBC example. We'll try that. And these are more of the execute, prepared statements and things like that. And we will see these things when we look into the database. Now in this one, they have gone in and done some formatting. So when you input some data and you extract the data, you can also do some grouping. You can alter the tables and things like that. But we'll probably not get into that much. We'll just do some sample. We'll still do everything that we do, that you see over here. All right, so for setting up the environment, now we talked about the database. Now we need to now have a database on our system. So take a look first and see if you have WAMP server on your machines, and this is probably true for only those people who are here. Those of you guys who have taken the 2700 class or have a SQL downloaded, you are still okay. If not, you can either download the WAMP server or you can download MySQL. Either one is fine. If you want to play with both, that is also okay. All right. So this one already has the WAMP server, but I'll show you the one that you can download the WAMP server from. So if you go to WAMP server. Is it org? I think it is. Nope. Com. Yes. So wampserver.com, okay, and make sure you choose the English, because a lot of times I've seen it would come, I think the basic language is French. So this is the English version. So, and this is, you can see this, and if I click on my oh, actually this is a different French or German or whatever. French, okay. So I'm going to go change to my simple plain old English, and if I click on my download, then it should let me download my file. And I think the last time I was checking, now for WAMP server you have to go through the source force. It would not let you download it directly. See this subdirectory. So depending upon if you have a 32-bit versus 64-bit, you're going to choose one from here. And if you click, this is the one that you go to download directly, and it will probably take you directly to your SourceForge. And then you can download the latest version, which is the WAMP server 3.1.3. Okay. Uh, Go with the regular default configuration. You don't have to change anything. So just keep clicking on next, 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 and you should be able to get your WAMP server downloaded. Okay. So basically you click over here, and then that would start your installation. I'm not going to do it because I think I have it, but this is for those of you guys who want to download the WAMP server. All right. So I'm going to come back and start my WAMP server here since I have it downloaded. This is the icon, and again, when you are going through the downloading phase, it's going to ask you if you want to have an icon or a shortcut created on your desktop, and I generally say yes, so that I have something on my desktop. And I do not know if I have it over here. Yes, right here. So that's my icon that I start my WAMP server. And it's not what I wanted. So this is my WAMP server here. I'm going to say OK. Now this icon, if it is working right, if the ports and everything is working right, it generally changes to a green color. Okay, so red is, it basically says none of these services are running, and green is when everything is running. So if you click on this, I'm going to stop, and I should be able to restart all my services, and it should change color, unless it's giving me some problems or errors. It's really not doing anything. What about you guys? Huh? So I'm going to start with this again. So now I'm trying to have two of these things going. Huh. It's kind of strange. It's not doing anything. Something with the some information about something about this set of computers. Generally, it's really not that difficult. If you just click on it, it should come open. What about any of you guys? Your WAMP servers running on the machines? You already have it? No? Oh, you're using your laptop. Okay, okay. But on your on the school PC, anybody's working, not working? So it's the same way, right? So if you click on it, nothing happens. Okay, so I'll probably have to go back and uninstall and reinstall something. So I'm going to do is um, I'm showing different ways. Another tool that you can use is the Heidi SQL. So I have an Heidi SQL over here that I downloaded, but you should also be able to download MySQL, which again, this should also be available over here. Let me see if it is available. See this MySQL over here? So this is, you can download the MySQL directly. So if I click over here, here is my command line that I would open. So let me show you where you can download your MySQL. Remember, you don't have to do all of them. You can only do one. You can go with the WAMP server, or you can download MySQL dot, is it com or org? So this is your MySQL, and if you click on download, you have to select the community download. There's a free version of it. There are also paid version, but we are good with the free version. So this is my MySQL community server, and if I click on MySQL community server, it's going to bring me to this page where I can basically choose my Windows version. So this is my installer, and what I'm going to do is click on the download page, which is going to take me to my MySQL MCI installer, and then from here I'm going to choose, I thought it had a 32 versus a 64, but either one of them you're going to be downloading. It is going to take a little while to get it all configured and set up, but once you have it, you should have MySQL installed on your computer. Again, remember, you do not need both. Either one is fine. If you want to do both, that is fine too. In the process of the MySQL download, it is going to ask you to set up your password. Okay, you need to make sure that you remember that password, because when we write our Java code, we will need to include that password there. Okay, so whatever password that you set up, make sure you remember it. So once you download and get it all set up, then just like this, you should be able to go to your program and scroll down to M, and this is going to set it up like a MySQL folder over here. And if you click open, you will see the MySQL command line. Okay, it's all going to be included in there. Now, within that community server, you're also going to find a tool called MySQL Workbench. I've had sometimes students who would tell me that when I download my community server, this one failed and I could not get to it. For our purpose, I do not need the workbench. Okay, so if you fail your workbench, don't worry about it. For our purpose, we would not need it. For my other class, I do use this as a tool, so I can go separately to MySQL and download the workbench separately as a tool. But for right now, if you have your MySQL downloaded, then you should be able to open it through the command line. Okay, so I'm going to open it through my command line, and this is where you need to input your password. I do not remember what my password was, so I'm going to try with the blank password, and it didn't like that. So I must have set up my password, and I will say root. Yes, so I may have set it up as root. This is not the most advisable way of doing it. Root is basically your master password. So when you set it up with your own password. Now, if you have your MySQL installed properly, when you run the command prompt, you should see this MySQL command. Okay, that tells you now you're ready to execute your SQL statements from here. So those of you guys who have, did you check on your computers to see if MySQL is there? Root, password. A lot of times I've asked people to set it up as COP2700. All right, so at this point, this is my screen where I'm going to type some very basic SQL statements, and this is part of your assignment, okay? So the first thing I would do is type in a basic SQL statement saying show databases. I have to end it with a semicolon, and if I hit enter, it shows me the databases that I have here. When you download MySQL for the first time, you would not see all of them. You probably would see the MySQL and maybe information schema. There are probably 2 or 3 that gets downloaded by default. So the screen that you see would probably not match when you download your MySQL. What you see over here is, as we were working through the class, we had created those individual databases. So for example, the one called MyTest or the one called Joomla, these are things that we had downloaded as a part of the class exercise. All right, everybody good? So once I have my MySQL and I see the databases that are there, now I need to go work with one single database. So these are all the databases that I have. So remember that big database system, you have multiple databases. So you're going to go work on one, okay? So the way I would choose one is to go and choose something called, let's say, use my underscore test semicolon. So now I'm going into my database called my underscore test. I hit enter and it says database changed. For your purpose, you may not have that my test, so go under whatever you have available. Maybe it is MySQL. You guys with me? All right, so whatever you have, go inside that. Could you get in, Jill? No? All right. So now I have database change, so which means I am now in my underscore test database. Now I'm going to type in show tables. So inside my database, I wanted to see what kind of tables do I have. Again, a semicolon, hit enter, and it says I only have one table, which is called user underscore details, right? So now I want to see what do I have in this table. Now before I do that, I can also do something like this. Describe user underscore details semicolon, which means I want to see what are my columns that I have, what are my data types that I have. Okay, so I said, all right, this particular table called user details have these columns: user ID, username, first name, last name, gender, password, and status. And it also gives me the data types that I have. See, my int, varchar, and then tells me which one of them are null. It also tells me which one of them is a primary key. And it also tells me this primary key that I have defined is an auto increment, so I don't have to type anything. As soon as I hit enter, or if I use a GUI tool, if I create a new line or a new row, automatically it's going to add its own primary key. All right, so now I want to see what are the kind of values that I have. So I can do one which says select asterisk, this is my wildcard, from user underscore details. So this statement basically means select everything, wildcard is that asterisk, from my table user underscore details. If I have values in there, if I hit enter, oh, So all these values that I have in here, I didn't realize I have so many values there. All right. 5,000 rows in a set. Okay. Now, that's a good thing that I do have some of these things here. So now I can do some select statements. So maybe I say, if I hit my upward arrow on my keyboard, it repeats my last command. Okay. Select asterisk from user details. I can say select, let's say, what is this column? Do you remember, any of you guys? What was it? Select. I want to find out the first name and the last name of those people who have a specific gender. All right, and I'm just making up things. Okay, so I'm going to say select first name, comma, last name from user underscore details where gender equals female. So now I have all this. So how many? I have about 2552 rows with first name and last name where the gender is female. Now you see that I do not have the column gender, because remember what I said. I said select first name, last name from the particular table where gender equal. But if I had said select first name, last name, and gender, comma, 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 from this table where this, then I would have another column associated with it. All right. Now, I can also say something like select first name, last name from gender equals female, or maybe say where coming over here, gender from user details where last name equals, let's try my name. Oh, 240 rows. So all these people with the last name Paul. Anyways, I think you get the point, right? So what we are doing here is, once we have the database installed on our computer, and our database could be either MySQL or it could be the WAMP server. Once we have it set up, I went to my command prompt and I wanted to make sure that I could access the database and I could access the tables that I have created in my database. Now, I worked with the tables that were already created, right? You can also write statements where you can create a new database, right? So remember those things you said. Now you are already in a database called user underscore details. All right. No, sorry. Yes, user underscore. No, that was the table. Yeah, the table name is user underscore details. I think the database was my underscore test. Okay. Now, if I want to create another table inside the same database, can I do that? Okay, what do? I say create table class, right? Within parentheses, write my column names, my varchars or integers, comma, the data types, and it would create my table. I can again come back and say show tables. Then in that database called my underscore test, now I have created another table called class. You guys good? Everybody know what I'm talking about? Yes, no, maybe? Okay. Now, let me go back to this. Now, I did open this thing right before I came. So, I have this assignment. Oops, not this one. Here we go. So, here is this assignment here. It's not what I'm trying to do. I'm trying to open this one up. Okay. So I said install MySQL on your computer. Okay. Now MySQL is the name of the database. You can do it two ways. You can do it with the WAMP server. WAMP server is a complete package. It stands for Windows, Apache, MySQL, PHP, WAMP. So it basically takes the first letter of all these terms: Windows, Apache, MySQL, PHP. If you are working with a MacBook, then you can download a MAMP server. Mac, Apache, MySQL, PHP. If you are working with a Linux environment, then you can download a LAMP, L-A-M-P. Okay, so that's one way of downloading that entire package. You are not concerned with any of the other three things. You only need that MySQL database. Now, if you do not want to do the MAMP, LAMP, or WAMP, then you can go to MySQL and download the MySQL directly. In that case, you are not going to get any language. You just download the MySQL database by itself. What I showed you is going through that MySQL command line. I could have shown the same thing through my WAMP server if my WAMP server was working. The way you would go through into the command line is if you click on the WAMP server, and again this should be turned green if the WAMP server was working. If you would have clicked on this, you can go to this MySQL and select the MySQL console, and that will take you directly to that command prompt that I just came in with my MySQL database. Everybody good? Okay. So you can do it both ways. So if you already have a WAMP server, you can use it for MySQL. But if you don't, just download your MySQL. Make sure you familiarize yourself with the command prompt and the GUI interface. Now, the GUI interface is if you download the WAMP server, but if you do not, then don't worry about it. I said and because that particular one I actually went through the WAMP server installation. So command prompt would be perfectly okay. Okay. For doing the following: create table, insert rows, insert data, update data, select statements, delete tables. All right. And then I have this thing where I said create a Java application that will establish the connection with the database that you had installed earlier. Okay, you can use the template program that you have used in the class. This part I have not given you yet. You guys with me? Okay, so for this assignment, I want you to be just familiar with this because it really is divided in two parts. One is you have to download your environment. You got to play with some of the SQL statement. What I did in class is basically showed you some select statements. Okay, but I did not create a table. I did not insert a row. I did not insert a data. I did not update any data. But in the PowerPoint, you saw some codes which does or shows you how to do it. All right. So in your command prompt, create a database. Okay, use the same format. Create a table. Insert a couple of values. Okay. Try to update one of the values there. Try to delete a table. Okay. You cannot mess it up. So practice this. The next time or the next class, we will have everybody set up their environment. They're all familiar with the SQL statement. We'll go directly into the Java application and we'll start writing or including some of the basic syntaxes inside your table. All right. And at that point, we should also be able to test our connection. Okay. So if I would have started testing my connection today, some of you guys, if you want to try it out with me, it would not work because you do not have the SQL set up yet. So any question on this? This assignment, I have opened it up, but you do not have to complete it by the next week because you do not have this part yet. But I want you to start playing with the first part. So install your SQL and then start playing with this, and we'll come back and do this. All right. So coming back over here, so this is where we were playing with our select statements, but you can always go ahead and create something, insert something, and that's what I want you to play with. Okay,